Hey everybody, here we are, problem number 9, 5-mark question. And my answer key is absolutely 100% accurate for this problem, but I was thinking about it today prior to recording this and thought there's got to be an easier way, and I found an easier way. So if you use the method on the answer key, absolutely right on, no big deal. You will get the correct answer, but I've got an easier way to go about it. So I'd like to, I've already kind of set the stage here with a sketch and some other stuff, so I'm going to describe what's going on here real quick and then we'll get into it. So I'm given the equation of this first plane, all information given. All right, and here's the visual of pi 1. And I'm given the second plane where I don't know the constant, right? I don't know k. But I do know that these two planes intersect at this line. So any point on that line is on both of those planes. So what I've done is I've taken and I've written this line in parametric form. So if you remember way back when we started studying this, each of these individually is equal to lambda. That's how we get this form for a line, okay? And this is called a Cartesian form for a line. Okay, so if I solve for lambda, let's say here, I would subtract 1 and divide by, excuse me, if I solve for x, I would subtract 1 and divide by 5. So that's how I get the x portion in this parametric form, the x component. Okay, same thing for y. I would subtract 9, divide by negative 5. Okay, and that's, of course, give me the y component. And then for z, I would just divide by negative 5. Okay, so now I've got this parametric form for the line. What I can do is any point on that line should also be on pi 1 as well as pi 2. So I'm going to choose to use lambda equal to 1 here. Okay, I'm going to plug in lambda equals 1. And that will give me a point on the line. Let's see, what would that give me? For x, that would be negative 1/5 plus 1/5, so 0. For y, 9/5 minus 1/5, which would be 8/5. And for z, that would be negative 1/5. Okay, so since that is on that line, it should also be in each of the planes. And if that's true, I should be able to solve for k. I don't even need pi 1 at all. So in for x, I'm going to plug in a 0. In for y, I'm going to plug in 8/5. And in for z, I'm going to plug in negative 1/5. So you can see that if you have checked the key, my work is entirely accurate, but it's pretty cumbersome and can be a little bit convoluted in nature. But here I'm just going to solve, and I'm going to get negative 8/5 minus 2/5 is equal to k, which is negative 10/5. Therefore, k has to equal negative 2. And that's it, guys. That's a 5-mark question. I don't really know how to allocate the points other than maybe, I don't know, maybe 1 mark here, 1 mark here, maybe even 2 marks here. Yeah, and then probably 1 mark for insert and 1 mark for the answer. That would be 5 marks altogether. If you went about it the way I did on the answer key, they would have to somehow adjust the allocation of each of those marks, but they would probably, it'd probably be heavy on the front end, and then the answer would just be 1 mark. So, all right, that's number 9. Shoot some questions if you got them.